Unit 1, Part 3, I can interpret a box plot. So for this example, we're going to be looking at a double histogram. For this example, we are going to be using a double box plot, so two box plots on the same number line, to compare how many basketballs Gym Class A and Gym Class B were able to get into the basketball hoop within 1 minute. So using two graphs on the same number line is a really good way to compare and contrast sets of data. So to start off, we are going to identify the 5-number summary. So for Class A, our minimum is 0. Our first quartile is between 2 and 4, which is 3. Our median, that middle number, is 7. Our upper quartile is 12. And our maximum is 20. Now for Gym Class B, our minimum is 3. Our lower quartile is 8. Our median, the halfway point, is 14. Upper quartile is 16, and the maximum is 18. All right, the IQR, or the interquartile range for each group, that just means we're going to subtract the upper quartile from the lower quartile. So for Class A, we're going to subtract 12 and 3. So we'll do 12 take away 3, which is 9. And then for Class B, upper quartile take away lower quartile. So we've got 16 take away 8, which is 8. All right, so a couple questions to answer now. If there are 28 students in Class A, how many students made more than 12 baskets? So if we're looking at Class A data set, that 12 is the upper quartile. That 12 is right here on our graph. So we're looking at how many students made more than 12 baskets. So remember that upper quartile is that 75% mark. So from 75 to 100% is just 1/4 of the data. 1/4 of the students would have made more than 28, or more than 12 baskets, excuse me. So what we need to know is we need to know 1/4 of 28. So we want to do 1/4 times 28, which is really just 28 divided by 4. Taking a fourth is just dividing by 4. And so we know that 7 students would have made more than 12 baskets if we had 28 students in Class A. Now, a similar question, if there are 36 students in Class B, how many students made less than 8 baskets? So if we look at our data, 8 in Class B is that lower quartile. It's right here, 8. And we're looking at less than. So again, still that lower quartile, which is going to be 1/4 of the data still, because we're in that first chunk of the data. So we can say that 1/4 of 36 students would have made less than 8 baskets. So we can do 36 divided by 4, which gives us 9. So then, which class is better at basketball? Looking at this data, Who do you think is the better class? Is it class A or class B? So right now I want you to think about that, and I want you to write down your answer and explain your reasoning. All right. Athletes were asked how many glasses of water they have per day. Their responses were 6, 7, Y, 8, Z, 8, X, 12, and 15. So these variables are going to be filled in by numbers, but right now we don't know what those variables are. What we do know, however, is our upper quartile, Q3, is 11, and our inner quartile range is 4. So if we think about our 5-number summary, we have our minimum, which we know from the data is 6. We have our lowest number. We also have our maximum, which is 15. Median in the middle, and then we have our Q1 and our Q3. We're told our Q3 is 11, and we're told our interquartile range is 4. Well, we know our interquartile range comes from doing Q3 take away Q1, and that's going to equal 4. I know that my Q3 is 11, so I can say 11 take away Q1, whatever that is going to equal 4. So then I can determine from that the value of Q1 is 7, because 11 take away 7 is 4. Now, we can also figure out the median by looking at our data set. So if we look here, we have an 8, then a Z, and then an 8. So I know Z is going to be 8 because no other number can go between 8 and 8 in a data set than 8 because we list numbers from least to greatest. So I know 8 is going to go there in the middle. So that's going to be 8. So now if I cross off numbers to find my median, find that middle number, I find out that that middle number is 8. So our median is 8. So now we have our 5-number summary. We need to find X and Y using our lower quartile and our upper quartile values. So we know 8 right here is our median value. So our lower quartile is 6, 7, Y, and 8. So the halfway point would be between 7 and Y. So what I know is that 7 plus whatever Y is divided by 2 is going to equal my quartile 1, my 7. Well, since the quartile 1 is 7, which matches the first number, I know that Y is going to be 7. If you want to walk through that mathematically, we just have to undo our operations. The opposite of dividing by 2 is multiplying by 2. So we can multiply this side by 2 to get rid of the 2's. Multiply this side by 2 and we get 14 equals, what we have left is that top, that numerator, 7 plus Y. 7 plus Y equals 14. Here we know that 7 plus 7 equals 14, so Y is 7. Then we do the same thing, but for the upper half. So our upper half of data is 8 through 15. So we have 8, X, 12, and 15. I know my quartile 3 is 11, so I'm going to cross off until I get to my middle value, which is between X and 12. So I'm going to do the same process here. I know that X plus 12 divided by 2 is going to equal my quartile 3 value of 11. I will undo that division with multiplication. Multiply both sides by 2. We get X plus 12 equals 11 times 2 is 22. And then we can undo that addition with subtraction. Take away 12 on both sides, and we get x equals 22 take away 12 is 10. So I know the value of x is 10. That is all the notes here for part 3. You can go ahead and move into the practice problems that you can try on your own.